So one more time, it will be better. So welcome everybody. Just come in, squeeze somewhere where it's still there's still quite a lot of places, and leave at least one place free for me here. Welcome to the afternoon session, maintaining ecological connectivity. We are going through quite a lot of presentation, not just the regular one, but also there will be several lighting sessions or lighting presentation as well. I'm Dusan Romportl from the Faculty of Science and also the Research Institute for Landscape, and I'm going to chair this session. We should start right now because we are just 1 minute late with the first presentation given by Manuela Panzacchi. So yeah, the floor is yours, Manu.
Hello, everybody. Manuela, I live in Norway and work mostly fermentation. So my focus is cumulative. This is not a big show for me. Obviously, this is an NGO that makes information to show the impact of human on. Hello? Okay. This is basically just a picture of Europe from sky, from space, and just to show how widespread we are. So the issue is that we've been just busy building a lot of stuff in the past centuries after the Industrial Revolution, and we have not really thought about the cumulative impact. So yes, this is a conference on infrastructure, transportation infrastructure, but I don't believe we can solve the problem just by looking at that. I believe we should look at the cumulative. And so we have been building all this stuff, but we didn't really look at the cumulative impact, but the cumulative impact speaks quite loud. Very dramatic projection for biodiversity. As people said before me today, we have to shift, have very clear what we want to achieve. And what I personally am interested in trying to contribute to is protection of biodiversity. And if the aim is to protect biodiversity, I think what we need to do is to shift between two perspectives. One is looking at the human network, and the other one is looking at the ecological as a network. When we talk about ecological network, what has been said also before, and I'm very happy to see that we are sharing the same concepts. We call functional area, highly functional area that are really good and well connected at the same time. Then there are other areas that are little functional. For instance, here you might have a little forest, but it's not supporting anything. I mean, it's supporting maybe an animal or two, but not a viable population in the future. So that's little function. Then we need to look into a corridor. And if you want to understand how to conserve biodiversity, we first have to quantify this four functional habitat, the corridors, and our cumulative impact, shifting between the human and the animal perspective at the same time. The thing is, how do we do it? And when I started working on this 20 years ago, we've been actually contacting quite a bit of colleagues internationally, doing literature review, and there was no method. Well, there was a lot of studies on cumulative impact, but nothing fundamentally and coherent, or theoretically and methodologically coherent. So we tried to figure out how to develop a theory of cumulative impacts. So each source of disturbance does two things. One, based on its type, I mean, what it is, hydropower is a different impact than a road, of how much it is, like one little cabin is different impact than many cabins or many roads, and where it is with respect to the species we're looking at. So each infrastructure has two impacts, one on habitat loss, one on fragmentation, the same thing. So the habitat lost due to a reservoir, you're taking away the habitat because it's flooded, but it also fragmented. And so far, ecologists are working on these two things for decades, but not together. So what we try to do is to bring these two things in the same methodological quantitative way. And this is, it's relatively easy conceptually because many species, many disciplines have been working on this for forever, from population ecology, metapopulation, species habitat, but also big data, algorithms. They've been developing these things, but these pieces, these disciplines were not really integrated. So what we try to do is we try to handpick the best guys around the world and bring them together to try to make a coherent framework to study cumulative impact and guide sustainable land. I won't go in the detail of the method because it's quite complicated. It's a network approach. Everything is online to check. But we are just making caricature on reindeer to show, because that was the species we used to develop. But everything I'm saying on reindeer, we also can apply to other species, as I will show after. Reindeer is very sensitive to disturbance because they're migratory. This is a picture of 7,000 reindeer migrating. If you put a road there, it's a problem. This is a caricature to explain the visual terms. This is a caricature of the landscape, say 1900 in South Norway. It's a real landscape. Then they built one of the biggest hydropower complexes. And then they also built quite a lot of other stuff. So our question is, how do you quantify the cumulative impact of this? And what is left for the species? What is functional? So first thing we do is many ways, niche modeling, species distribution, what to do to calculate the habitat lost, given the density of infrastructure, the distance to infrastructure, and so on. So there are many different approaches. So the black here is what is there. And then we also have to quantify the barriers. We tend to analyze them. So we tend to use statistics to assess this thing. We could also use expert base, which we do in some cases. We don't have the data, but we have trajectory data, then we analyze this. And the point is, this, if you have to get one thing on my presentation, this green blob is what is important. This is what is left for the species. So, because there is also good habitat. There's also good habitat here, here, and here. So if you look at habitat loss, habitat available, it's a lot. What is actually there for the species is only what is available and connected. So once you quantify that, and we do that using network models, you can see what happens if you build wind power. So what happens is that you lose access to the top part. So you lose, say, 30 square meters. If you restore the habitat in the middle, what happens is that you gain access to this thing. So then you can quantify what happened. If you do mitigation measure, you can quantify what happened to building roads. And so just to synthesize everything I said, first we focus on each 100 meters. We work in Norway at the Norwegian scale, but first we look at what is around here. Is there some good food for my reindeer? Can a reindeer stay where I am? Then you're looking at the barriers. Can a reindeer cross this wall, or does he have to take the road, the open door to get out? So we quantify the permeability. And then we bring this together with a network approach. We have made a software for that, but there are many ways to do this. And then we can support sustainable. So it's one theoretical and coherent approach, and then applied results. Just to show the result on reindeer, this is just the habitat suitability. You can get this to sustainable resource selection function. You can do sort. And we have a lot of variables. So we consider both human activities, like, for example, the density of houses has an effect up to 10 kilometers, so it's a global increase, and the effect is minus 0.3. The effect of road with a lot of traffic, the effect of road with less traffic, private cabins, and a lot of environmental variables, water, topography. So this is the means for rentals. And we have it, you can also, we have a dashboard where you can see each area in Norway, like this is water, hydropower, what is the effect of the area, what is the effect of roads. So you can really quantify. We can separate the different drivers each area. The same map we made for barriers. All these variables indicate how likely it is a reindeer to cross traffic, so. And then we bring them together. So these two on the right are the one I just explained. So this is quality, good stuff. This is barriers. So if you look inside this circle, you see that yes, you have good habitat. However, here you have a big barrier. So there's no corridor getting in, and that's not functional. So this is what we need to quantify in order to be able to do sustainable land. And then we do a lot of scenarios to simulate the effect of building. We simulate what happens to the roads, the power, raise the road, we change traffic volume, reduce the volume. if you move roads into tunnel. This is an example. We have an area we built especially before the hydropower. And what happened is that the corridors that before were with everywhere, you see the corridors before they were with everywhere, and now the rain had to pass exactly in this little point, where, by the way, all the human infrastructure also go, roads, businesses. So now we are planning defragmentation strategy in the area. And we calculate that if you just look at the habitat, the area lost, the land lost, is 100 kilometers. But if you look at the functional habitat loss, the landscapes is more than double. Same thing here, we did a simulation where that is not happening. Yes, the area. We remove the tourist cabin, trails, and roads. And you see what happened if you remove it before. Actually, this has happened. So, unfortunately, you don't see the picture, but there is a digger there that is kind of restoring the habitat. So, it's putting back natural species to cover the previous road. It has been done, so this is another example to show that yes, all models are wrong. And the first one to say that we work on it all the time, but they can get more accurate. So this is an area where we predicted this corridor with the information measure there, and we predicted that the reindeer, now this is GPS position in green, and our corridors are predicted there. So we said, well, the reindeer now they're not passing anymore. But if you want to reconnect them, we could do two corridors, one here and one there. When we did the study, the reindeer crossed quite precisely that one. So it can be, when you use also local data, you can increase the precision quite a lot. So we did more than 80 scenarios in Norway where we place roads, build bridges over the power. Usually we don't do a scenario only of roads. Sometimes we do, but usually we try to open a corridor. So we think about the reindeers. If there is a road, and you just close a road, but then you have we try to bring everything together. And this scenario are suggested by local people, explored the local people that suggest maybe it can be distributed in banks. This is the last cherry on the cake we are trying to develop now. The paper is published, but we are still figuring out. So once you have a corridor, you can also do a sensitivity analysis to see if I am doing this is a migration route of reindeer, and this is a road in the middle. So that sensitivity analyzer said, well, if I ruin the corridor, in which place would I do most damage? So these red areas are the areas that you should really not touch, because if you touch that point, your network collapses. So the question that everybody have, we don't have reindeer in Europe, not much. Can this be applied to other species? So we're doing this in a new project that we are running now, where the aim is exactly this, to extend to all species with less good data than reindeer. So we do, here you have 3 examples, moose, beetles, and pollinators. We do more. The idea is the same. So we make the same maps. We are making an ecological network database, which is already online. And then we're trying to synthesize them, to bring them together, and basically into one map, saying, if I have to observe habitat, thinking about these 3 species, which would be the most less compromised. I'm a proponent of the species-specific approach. I think we should include like species in order to be able to protect the species. But if the land manager says, well, I want to protect these 3 species, now you're looking in the landscape, which are the relatively most relevant for the 3 species together. And then we can do mitigation. This is a prototype app where we do exactly this. Here we can select species. This is an example. You can give a weight. So, well, I care more about these. I don't care much about pollinators. And then you can find, you can optimize the curve. Then you get the. So far, we have a net quarter with the species online. This is for moose. The same message before. This is a zooming, and as we're showing the corridor, is quite precise. It's only 100 meter resolution. And this has been actually validated with multiple collision data. So we see that this X explains the corridor. So the more we predict that there is a corridor up there, the more there's cars on the road, traffic volume, the more it's likely to be a collision. pollution. So that's the places for pollution. If you also map for pollinators, you know, better. First model, and you're making also the connectivity map for trees, where we show the habitat is going to save what we do in time, so we climate change. And so we have the stability now, and for the most of the deciduous species, the habitat will increase. Or so it's spread. While for the species, actually, you can see quite a dramatic decline. Sorry, Swedish people from Sweden. So it will be a shift in composition. But this is a dramatic map and does not take into account connectivity. When you put connectivity, this is about the deciduous forest. Norway is only the green marks, only this. The suitable habitat in 100 years is all the blue. But actually, if you look at it's only, that's why it's important to look into the last slide is about I'm a proponent of species-specific approach, but we're also trying something else. So this is a map of connectivity for whole forest species. We put forest maps, we looked at the age, we selected a very old forest, we looked at the dispersal distance of 5 kilometers, and this is what we did. I don't think this map means a lot, because it's writing. And they really like it, and it probably has some meaning, but it's not just to say that there can be different options. Thank you very much.
Thank Manuela for a great presentation. We have 3-4 minutes for some quick question. Are there any? Yep.
Thank you very much. Very interesting. Could you tell maybe something about how you parameterize the habitat suitability maps and which variables you take into account for this?
So we use resource selection function in the ones that I showed, and we're using 250 variables, including vegetation, infrastructure, density, calculated density of infrastructure, so on roads and cabins, given radius, temperature, topography, you name it. And it's just a suitability resource selection function. So you consider where the animal is seen, where what the characteristics are there, and you predict. And we run finish mapping.
Are there any other questions, comments? No, you can continue your discussion with Manuel, which will after the session. Let's continue with the next presentation. Is here. Vladimir Perumal. Yeah, okay. Maybe I didn't pronounce your name correctly.
Wow. Hi, everyone. My name's Lavinia. And today I'm going to be presenting some of my work for my PhD. And this is about to be published, so feedback is welcome. And it's titled basically Assessing the Influence of Road Density on Land Cover Patterns Across Ecosystems. So a bit of setting the scene. I'm sure you all know that there's all this proposed road development, major infrastructure development for Africa that's about to happen. And then there's everything that I've been hearing since I got here about what roads do. And I'm sort of new to road ecology, but so we have mapped the major pathways through which roads might impact ecosystems. And the pathway I'm looking at here is the land use pathway. So roads incentivizing or enabling land use change. So that's one of the pathways in which roads might impact ecosystems and biodiversity. So yeah, I've put a round circle around all of that to say that basically land use change can occur almost immediately adjacent to the road or anywhere up to 50 kilometers from the road. So the motivation behind this is because the long-term effects of road infrastructure on broad-scale land cover patterns is not well understood. And if it is understood, it's largely from other disciplines such as urban geography or transport economics. So the evidence is quite scattered. So for example, we have evidence of people saying that road development will lead to cultivation and agriculture. Okay, not really looking at what that means for biodiversity or ecosystems. So typically, road infrastructure development is studied separately from land use or land system science. The other fact here is that there's widespread agreement that transport systems and land use affect each other, but there is not consensus on how they actually do this. And the major concern from an African perspective is unregulated land cover change, which is detrimental to biodiversity, and all of the indirect drivers such as population, urbanization, and the usuals. So a little bit here is, I don't know if you've ever seen this sort of transport land use cycle. And it's basically what happens is when we build a road, we increase mobility and accessibility, and we make the area more attractive, incentivizing land conversion and land use change at possibly the expense of natural land cover and thus habitat loss. So road development is likely to catalyze actions that lead to land loss because roads are a prerequisite for land development and land activity. So on the right is basically a diagram of what I've just said. It leads to land conversions. And the idea here is that major road infrastructure development in Africa will reorganize, rearrange the spatial distribution of land cover parcels and land use across the continent. So it's expected to facilitate large-scale developments. And my interest is in sub-Saharan Africa. And I don't think that we have contextually relevant literature on what roads do in terms of land cover change. A lot of what we understand about land change comes from the Amazon, for example, where we can easily quantify change through satellite imagery. The other point here is that land use does not just depend on road infrastructure, it depends on a whole lot of other factors. That was me trying to get ChatGPT to produce some image of what I'm trying to do is trying to basically test whether road, and I'm using road density in this analysis. So basically we're using a gradient boosted algorithm, which is a machine learning algorithm to try and characterize what drives or what explains land cover patterns in different ecosystem types. And one of the drivers or two of the potential predictors of land cover patterns is access road density and mobility road density. Those are two different types of roads, big roads and small roads. And so basically we want to establish whether road density can explain some of the land cover patterns that we have. And how we're doing this is, I don't know if you know South Africa, but that's what it looks like. Basically, we're just going to model the characteristics using a set of what we believe are influential predictors of land cover patterns. We treat them equally. So for example, what explains land cover is population, GDP contribution, terrain, distance from a town, rainfall, protected area distance. So we plug in a whole lot of factors and we try to model what land cover patterns look like and what explains it. And there are 9 biomes in South Africa. So that gives us ecological context. So we understand the context under which different patterns might occur and how the influence of roads and the role of roads and different types of roads might affect land cover patterns. So very quickly, an overview of what we found. So those are our biomes. So for some context, roads were built in South Africa. We don't have good ideas of exactly when, but maybe about 80 years ago. And since then, not much new road construction has happened. from the models, what we are seeing is that land cover patterns are largely explained by other drivers such as population, rainfall, topographic complexity, so which is how vertically complex the terrain is. The access road density and mobility road density were not the main drivers of long-term land cover trends. So it means that they had less impact on the model's ability to predict. So basically, we are inferring that if a variable is important for predicting land cover, it means that that variable has a strong relationship to land cover. And this is kind of saying that the mobility road density, so that's big roads and freeways and highways, and access roads, so the smaller streets and main roads, is not directly explaining land cover patterns in South African biomes. Yet we can see that it does vary. For example, so in the succulent Karoo, which is a sort of arid biome, we see that small roads are quite important. And I'll get to why in a bit. But that's the other thing, is that what drives land cover patterns is different. So unpacking this at a national level, yes, it does give us insight, but when you go deeper into a biome level, so an ecosystem, we see that patterns are very different. So this is just basically what we did a step further, is to interpret our predictions and just to verify whether some of these features are actually explaining land cover patterns. And you can see that as rainfall increases, we start to see the proportion of natural land cover, which is what we model, obviously starts to decrease. So land becomes more suitable for use. As economic activity increases, we start to see land use increase or natural land cover decrease. It's the same with population density, but we see a steeper trend. What is interesting is you'll see a lot of trends start to saturate, which means basically, like if you look at population density, if I were to increase population density, this is a 6 kilometer area, if I were to increase it by 1,000 people, it typically will not change the amount of natural cover in that area because there is possibly a development threshold that we've reached. So this is looking at access road density. And basically, as you can see, it was really hard to isolate the effects of roads because these roads were built a really long time ago. And as you may know, when we build roads, you might see a strong effect immediately after the road is constructed. But if you were to look at the landscape 80 years after the road is constructed, to be able to attribute what is happening to the road is very difficult because what is happening in that area is likely a consequence of population or economic activity. The road was substantial further back, so it was enabling change, but it isn't necessarily driving further change. So that's basically what we're showing here. And you'll see that a lot of the results are for the top part. That's because South we have fairly high natural land cover, and we see very small effects. But you can see, if you look at the black trends, you'll see that as we increase access road density in an area, the proportion of natural cover decreases. Oh, and the one thing about why access roads, small roads, may be important in arid areas is because biomes like the succulent Karoo are arid, so land use options are limited. So it's usually built up settlements and buildings and those sorts of activities. And it's not like large scale agriculture that needs highways. Similar thing here with mobility road density. So these are your highways. And I just want to point out, so this one on, can't tell left and right, but the Indian Ocean coastal belt. So we can see that as we increase mobility road density in an area, we start to see that the amount of natural cover in an area decreases, right? That kind of makes sense. But what is interesting about the Indian Ocean coastal belt is a lot of this is occurring in peri-urban areas. So there's a lot of urban expansion that's happening, and we're finding that population and settlement is kind of growing along the highways. So what it's saying is that even 80 years after, road development can actually still support land use change, although not as strong as other factors. I don't know how much time I have left. Okay. So sorry if I'm rushing, but this is a little bit about what I find a little bit interesting. So we found that maybe those access roads and mobility roads were features that were not directly explaining land cover patterns. But what's interesting is when you model their interactions. So for example, if I looked at small roads and big roads in an area, does that make a difference? And yes, for example, in the Indian Ocean coastal belt, you can see that those areas that have both a lot of big roads and a lot of small roads obviously have lower natural cover. So what that is implying is that an area that has highways and small streets is more connected and more accessible. So what we're saying is that more accessibility and more connectivity is more likely to change land cover versus an area, for example, like the succulent Karoo, where you can see that if we were to increase mobility roads or big roads, it's not really changing anything. But if we were to increase small road densities, then it's changing something. So it's telling you that the land use activity in that area strongly depends on a certain type of road. The same with population density. So the Albany ticket, that's an AT. It's basically saying that as we increase population density, and so, hold on. So higher population density, areas with a higher population density and areas with higher mobility road density have more intense land use. So this is interesting because it is sort of saying that if I were to increase population density on its own, it would not have the same effect as if I were to increase both population density and highways. And then the last one there is GDP contribution, which is basically economic activity. So it's also saying that land cover change is predicted to be greater in an area that has more mobility roads. So areas that have bigger highways and freeways have a greater economic contribution than those that have fewer highways. Yeah, and then you see in that arid biome, it's still again telling you that small roads are important for economic activity. This is looking at the lesser important variables, but interesting, the only few things I'll point out is when I look at distance from a town. So for example, in a grassland or a savanna biome, we have rural areas in South Africa, which are quite far away from towns, right? And not as developed. And interestingly, we find that if we put, what the model is showing is that the probability for land cover conversion is higher in a rural area if it has more freeways and highways, which kind of makes sense, right? But we're not finding that everywhere. In the arid biomes, if we do that, it doesn't do anything. Topographic complexity, so that's how terrain, how rough the terrain is. Usually, terrain is a driver of change, so independently, terrain is much stronger. But if I were to put roads in an area that was topographically complex, it would make the area accessible, which increases the probability of the areas, the likelihood to change. Same thing, distance from a river, so rivers are very important in the arid biomes. And what we found was that usually you get lush vegetation around the river, but if I were to put small access roads along the river, significant difference in land change. Same thing with rainfall, which is interesting because what that is telling you is that if I were to increase roads, mobility roads in areas with sufficient rainfall, more likely to get land use. So that is telling you it's probably supporting rainfall-led agriculture. The distance from a protected area was I'm still working with that, but what was interesting was that areas around protected areas, if we had highways and freeways around protected areas, the likelihood of land change was higher versus those that didn't have big roads around. So just disclaimer, this is not telling you, there's no causality here. This is egg and a chicken kind of thing. I'm not telling you that population is driving change or GDP is driving change. It's merely an association between variables, between a variable and land cover patterns. The study is only exploring this type of impact. Roads have other impacts. So likely that roads are directly driving change, but what we see here, especially in the long term, it's more indirect driving of change. It is very difficult to isolate because the impact of a road is complex. changing over time. The impact 1 year of some road is different to 80 years of a road. Yeah, and perhaps changing road density on its own is insufficient for bringing about significant land use change. But roads do indeed favor a certain pathway of change. So they enable change, but in the long term, I don't know whether they drive change. Yeah, so one thing to note, I don't know if there are any land system scientists in the room, but I do think that we should consider road infrastructure development in land cover models. We are often using land cover models to predict what will happen in the future and what that means for biodiversity. But we often ignore the extensive road infrastructure development that will happen across Africa. Thank you.
Thanks for presentation. Are there any questions or comments?
Thank you for nice presentation. I just wanted to ask, I tried to understand right direction, but you mentioned that there is some area with low accessibility 2 minutes ago. And if you will build road, probably it will increase density of population or change landscape forward. My question, what about if we build a highway? Maybe it will be two targets of this road, like go through this area or go into this area. Is different meaning of this road. Therefore, I think it will be a question not about settlement. You pass through this way, through this area, so landscape probably will not change so much. So just please comment this.
Yeah, it is interesting. What we found is that terrain is by far a much stronger driver of change. So roads merely moderate the effect of terrain. So if I were to put a big road into an area that was complex, all we are saying here is that it increases the probability of change. And I agree that where the function of the road and where the road is going to and where it's coming from is quite important. But for instance, we found distance like to a town, which is an economic hub, was not really important. Perhaps because people have increased connectivity even without the road, right? So there's what do you call this, ICTS infrastructure, so communication infrastructure and all of these things. So people actually use the road, but it would be interesting to see what types of land use activity might occur in terrain like that. But I imagine it's definitely not going to be as intensive because the terrain restricts the area. So yeah, I suppose it depends on the ecological or the landscape.
Are there any other questions or comments? So thanks again for the presentation, and we will move from roads of South Africa to railways of Baltic states. I'm not sure about, yeah, I'm sorry, I didn't write down the name of.
We will be doing that in a duet. I will do a shorter introduction and then over forward to my colleagues. Yes. So I'm myself, I'm from Latvia, and this is my colleague Kart from Estonia. Shortly presenting the Rail Baltica. Oh, closer, right? It's always a fear not to spit and, do the sound. So, yeah. Closer to the screen. Then that's the sound. Yeah. Okay. Thanks. We will shortly tell about the project and then we'll move on more specifically on the Estonian example. But just as a short intro, it first of all is really an honor to be in this, oh my God, the Society of Scientists. And most of the presentations, they're very, very deeply scientific and showing results of specific projects. We deliberately chose our topic to be more on the governance and legislative framework level, because that's something that we are currently pondering and thinking about. And we expect or hope to get some feedback, maybe also from you in the audience, and then during the breaks and communications, just to understand how you solved or your governments have solved, and are we heading in the right directions? So a bit shortly about the project. It's a project of 3 countries, Latvia, Estonia, and of course Lithuania. And it's first high-speed railway project. And we're also a very, very complex institutional-wise how we implement it. I'm representing a centralized unit that's just created for the purposes of development and implementation of this project to have a coordinated, a bit as far as we can, a coordinated approach. But then, of course, the implementing bodies, implementing countries are all 3 of our countries. Part is representing Estonian unit who they're actually implementing the project for that country. So it's really complex just to understand what are the common problems, how to manage that we at least design and construct in a way that's interoperable and same approaches also towards the environment. But then we, of course, have those additional legislative things, and then sometimes they're not even comparable because the systems also differ. And what types of decisions made by municipalities, what are centralized, all those things. So it's a very, very complex project. But just shortly about the project itself, yesterday, I think most of us and you listened also to the keynote speech, and I liked also there was this comparison of those 2 very important aspects. One is the mobility, and the other one is the need for new infrastructure. So when we look at the Rail Baltica project, we really see that those both are needed, even though it's a new infrastructure, and then one could question why it's really needed. That's why the context. We used to have railway that's in the same gauge and gauges that the distance between the tracks as most of the Europe. But then Soviets came, and during the occupation, it was like intentionally destroyed and changed to absolutely different widths so that we don't have the mobility anymore. We have it within our very closed iron curtain system, but we don't have the access for the rest of Europe. So now we are facing the problem that if we want to go somewhere here in Europe, we really don't have any reasonable options as the ones that are totally against the Green Deal. It's the air travel, even to the shorter distances like now. If I had to come here, of course, with an airplane, or the distance would be really long with the car. And for the freight and passenger transport as well, it's the only other option is traffic by road. And then, of course, sea, but still we all understand that electrified rail is kind of future, specifically if you also consider what type of electricity it's being used. So we are acknowledged also on the European level as a needed project and included in the TNT corridor. Because if you look at the picture, that's us. And we can't go up north and we can't go down south. We're really actually isolated. So it's included in a very important corridor of this Black Sea, but of course also now in the new revised TNT regulation, it's included also in this future corridor connecting Ukraine. And it's one more aspect now to the Rail Baltica project emerging in the last years. It's because of the geopolitical situation, it's actually also a necessity because of the transportation of goods, because of the military mobility. So those things are also considered and recognized at the European level. So we as a project sit in a context where we really do have to build this railway, but we have to, of course, build it in a conscious way, in a way that we take into account the effects that we are having on environment. So we can move to the next slide, please. Just to give the context of the magnitude. So it's 3 countries. It's the first ever high-speed railway in all of our countries. And it's, again, not one country project, but 3 country projects. It's close to 900 kilometers if we measure the straight line. And we just look at the picture and understand what that means environmentally wise. It's a greenfield project, so we have to find a place where to put it so that we find a compromise between all those various aspects. And then we also have to understand that we can't neglect the aspect of connectivity, because if you just look at it, we understand that it's dividing the countries into sides, and if we are not considering the integrity of those 2 sides, then we are absolutely doing the damage to the environment. So the structure-wise, it's more than 90 structures like bridges and viaducts, the ones that are for the infrastructure. And we're just building or planning one of those would be like a big environmental impact system and understanding how to do it to mitigate the impacts. But we have to do it for the whole line, also for the structures, how to cross rivers, how to cross roads, and also the micromobility of humans as well as ecosystem elements. So it's a planning process started long ago with the active process since 2015 and 2016 when first special plannings and environmental assessments started. Now we are at the stage where the designs are closing to be finalized. A few of the sections still ongoing designs and we're starting construction. And about the wildlife, the migration possibilities, it's like enormous amount of studies and also, of course, in-field monitoring, how to understand where exactly we have to put what kind of structures and to manage it in a way that it's consistent in all three countries. We have developed a system so that we have design guidelines that are technical guidelines that are like, we have to apply them all across. And then, of course, all those national things that come in, then we have to understand what it's contradicting or not and how to apply them both the viable guideline, what's being used, designing, of course, the structures is IENE handbook and all those beautiful examples, what and those do's and don'ts, how to plan them. And then, of course, when we go down to each specific case, that's tailored to the case, and of course, using the experience and recommendations and requirements that come from experts. And at this point, I give over to you.
Thank you.
Again, in our problematic. Just checking that it's working. Yes.
And please let me know if you can hear me, because I'm not really used to those things. My singing career didn't quite take off, so. Okay, as Vita said, I'm environmental and sustainability lead for the Estonian section of Rail Baltica. So I'll talk a little bit of the practical aspects of implementing this project. The over 1,000 wildlife crossings there is greatly an underestimation in the number. Even in Estonian section, we would have more than 1,000. If you count every crossing, obviously there's lots of different culverts and bigger culverts, smaller culverts, different species. But I'll talk a bit more about the actual ecoducts because there's a very specific issue that we have faced there that I want to tell you about. So I'll go to the next slide. I took this brochure because I wanted to show you. I'm sure you've all seen this picture many times now. I wanted to talk about why we don't have this luxury here that on this photo. In Estonia, we have a very flat landscape, which means that every single ecoduct we are building bar one are in a situation where the land is flat and we are creating an overpass for the animals. We don't have much opportunity to create a trench for the railway because just literally on flat land. That means that we are creating a mound for the animals, which also means that in terms of land clearing, we need to clear a big area because we need to create a mound that has the slope that animals can actually walk up from. So in terms of land clearing, so you kind of get the perspective, this corridor is cleared in about 50 meter width. Where the ecoducts are built, we are clearing about 250 to even 300 meters of width. So it's quite a big area that's being cleared. A mound is created, and then obviously that habitat needs to be then restored and connected again also in the landscape. And I won't go much into detail on this picture because I'm sure there's many people here who know more about this than me. But just very quickly, obviously there's the base area of the ecoduct where the aim is to sort of blend the ecoduct back into the surrounding landscape to make sure that the animals do get to that. Then there's the passage area where we're talking about creating pathways for different animals to get to the structure itself, where there are hiding opportunities in sort of, we created this, I think they're called debris mounds on this slide, but they're pretty much just roots or piles of logs and branches for the small animals to hide in. There's a planting scheme that follows both sort of hiding the railway from the animals, but also creating then a bit of a forest cover where it's needed. And there's also ponds put in there both for the amphibians as a habitat, but also to attract animals for drinking locations. So that's what we can do around the immediate vicinity of the ecoduct to make sure that animals do come to that. And this concept has been put together by a team of people. It's being implemented pretty uniformly across the alignment. In Estonia, we have about 90 structures that Iveta spoke about. Just under 40 are ecoducts in Estonia. In a couple of cases, this looks a little bit different. The slopes may differ a little bit, but it's pretty uniform. Now, the next step from there is what happens around that ecoduct. And this is where we have really encountered a problem that we need to solve. So while the ecoduct itself gets reforested, next to the ecoduct, there are lands that are now outside of the railway alignment that very often belong to private owners. So what we have seen elsewhere is that what can happen then is that the landowner may just think that's a good time now to clear this forest. And what we end up is with a big deforested area next to the ecoduct. Obviously, that's a problem. And that creates, it breaks that continuity in the landscape for the animals to actually get to that. Clearly, there's other pressures around these areas where in Estonia, we are in the north of Estonia, we're in areas where there are quite a lot of development pressure in these areas as well. Also, obviously, the railway isn't going through only forest. It's going through areas where urbanization is sort of ramping up around the capital. And there's clearly a pressure around everywhere around the alignment to extract resources to build the actual railway. So there's also a lot of pressure in terms of mining permits and such. So that has created a situation where we have identified that there's a need to protect the surrounding of the ecoduct to maintain that landscape. The bigger picture there is that for example, in Estonia, and Iveta can comment later on across other countries, but in Estonia, although we have placed those ecoducts on existing green corridors that are already legislated somehow through county plans and local area plans, the restrictions in those green corridors vary greatly. The local governments have implemented different restrictions. So it's very difficult for us to have this certainty or go in and make sure that that everywhere this area around the aqueduct is protected. Might just show the next slide with that. Just from there on, the question is, and how do we regulate this? How do we go further from what we currently have? Where does that regulation sit? Is that a national regulation? Is that a regional regulation, or can we just do on with the current, but have more sort of structure around the local plans? So what we have come up with as an option that is currently being worked into a legislation is a nationwide legislation for those protection zones. We have come up with a concept that more or less 500 meters around the ecoduct is an area that needs special protection, and that protection should be stricter than elsewhere in the corridor. If within green corridors we are talking about maintaining the land use similar to previous in general, then in those protection zones, because there are bottlenecks, we're talking about more intensive protection than elsewhere. That 500-meter zone itself is a sort of general approach where to start from. What we have seen from there on is that there's a need to then further specify that zone around the aqueduct. It's dependent on the land use around it. We have identified that it's better to cut out areas where there is existing households or existing, for example, industrial area bordering that area. Just to make it easier to set uniform restrictions for that. There's two examples here on the slide. One of them is an example where the protection zone as identified by a wildlife expert is more or less that 500-meter zone with a little bit of an exception there. And the other one is a more sort of transformed shape. On one side of that, where you can see that this zone itself has been got quite narrow, that's where there's an existing protected area. And there was no need to have that zone over that protected area already. And elsewhere, you would see that this protected area border follows the forest mass. And now the next question is what the restrictions are that should be in those zones. Should one be allowed to hunt in there? And if so, what sort of hunting and what conditions should you be able to do any forestry, like any forest cleaning, or should we just ban clearing the forest, but we should allow some sort of forestry? So we have also defined those measures in more detail with exceptions allowed. This hasn't currently been it hasn't set yet in legislation, but there's a proposal that's been worked out, and hopefully by the end of the year, I could say that there is a law that regulates that in Estonia. I think I'm running out of time, so I think I'll stop here and can just go with the questions.
Thanks. Oh, sorry. Thanks for presentation. I would like to say good luck with such a huge project. But yeah, I like the approach. Are there any questions? We have 3 minutes for questions.
Thank you very much. My name is Radu Moț. One question, please. Considering the flat terrain and the complication of building overpasses, have you considered enlarging the underpasses? So we can talk about underpasses, culverts or bridges required by other reasons than wildlife passages. But by increasing the size of them and taking care of by features, they could actually be a good passageways for wildlife. Thank you.
Short answer is yes. Again, Iveta can add, but in Estonia, we have about, I think, 10 structures where what we consider currently, and it could be more because we haven't finished the whole alignment planning yet, what we call the lengthened bridges, where it's mainly river bridges. So obviously the river banks are where the animals like to move. So we have allowed for that, crossing rivers. Where the railway height allows it, there are under passes. However, there are many animals, and I'm not the right person to comment, but there are many animals that wouldn't go under, for example, 3-meter passage, like moose would want much higher under passage. So there's limitations to that, what we can do. That's it.
Just to add, so, yeah, that's exactly what we're doing wherever possible. Also, when the corridors are assessed and experts recommend what type of structure is needed where. So if there is a possibility to use those kind of structures, that's definitely used. And we have, of course, the parameters depending on the species who go there, how you have to make it, how high, specific zone where they can walk safely and all those things. And then taking those out, and still we see where it's absolutely needed, because ecological is also a very costly structure. So whenever, of course, it's possible, it's not that it's avoided, but we look and dig in, can we do it differently? And we even have a lot of forest lands in Latvia, for example, when we just have those very, very small forest roads, then together with the forestry organization, we're also maintaining it lately, we analyze the traffic, and if it's possible, then it's both for the traffic and also for the animals, following the guidelines. But still, we can't avoid also having these structures. And then again, when we talk about these possible restrictions that are needed so that in the future in the operation it really does work, and we haven't thrown a lot of money in there and then we have to mitigate because something has changed around, we also think that those restrictions it's not needed only for the aqueducts, It's the same if you build a culvert that's specifically also adapted, and then I don't know, somebody builds a gas tank just there. That's again creating asphalt land, well, and it doesn't work anymore. So we just encounter all of the time the situation where we understand that just to let it be regulated by the local municipalities, with just having some kind of general guideline doesn't necessarily lead to the needed result in the future. But when we talk and also with the legislators about possible restrictions, then of course the question that pops up, what about compensations? So to understand, is it just a need deriving from the project, and that should be something that is also covered by the project, or it's again, so many different types of questions are being asked. And if we put a general line, 500 meters, for example, it's a bit more easy for at least in Latvia to have, as an example, a law on protected belts. And then you have just, you have some type of object where you set the belt, and there are those restrictions. It's set by law, by parliament. Everybody just have to live with it. But how to set generally something that there will be a zone, but you will know the zone when sometime an ecologist will say exactly where it is, and then you will see some kind of system. Then again, legislators just say, don't come with such proposal. It's really complex, and we try to contact also colleagues with twinning projects we have in other European countries to understand how it's legislated, and we haven't yet received like a clear picture how it's being done. Because for Estonia and Lithuania, the experience also with roads that are fenced, and then we need the crossing structures. It's kind of new thing in Latvia. We just currently, the latest projects for highways, first highways, are where you have the fenced, parameter fenced areas. Usually it's just, you have to put the speed limitation but let the animals cross. So this is going to be the first fenced high-speed thing infrastructure object. We don't have a single aqueduct like specifically designed, analyzing the corridors. So of course we have also knowledge and legislative gaps. So we found, if there are any good examples of how it's done, to from centralized top from top down. We're just very happy to hear.
Yeah, thank you. We are running out of time. So I think that there will be plenty of occasions to discuss this complex approach, or the possibilities from some examples from other countries. So we will now. There's a set of 5 lightning talks ahead. So we start with the first lightning presentation given by Silvia Borlea from Romania. So the floor is yours.
Thank you very much. Thank you for attending this lightning talk. My name is Silvia Borlea. I will have a short presentation on an updated permeability and infrastructure conflict map of Romania. A few short words about us. I'm from EPC Environmental Consulting. We are consultants. We have a team of biologists, ecologists, engineers, geographers. We know some of you from our previous projects that we worked for the last few years. We worked in TransGreen, in Bison, in Safe Green, with our partners from Zarand Association as well, and other partners as well. This map developed sort of as a need, because Romania doesn't have an official ecological corridor map at the national level. It has certain independent developments, let's say, but nothing that is official, nothing that is approved. So we wanted to provide a better understanding of the ecological connectivity in Romania. We wanted to provide an updated map, taking into consideration new and upcoming major roads and railway projects. We wanted to highlight the projects which are most likely to affect ecological connectivity, and we wanted to indicate the locations where defragmentation measures are necessary. This is something that we've done independently, let's say, because as I said, we don't really have any support from the National Road Association or anyone, the National Road Company, or anyone of the state-owned institutions. This is something that we've started from. This is a map from 2008. It's called the Natur Regio map. It was a project that was done a long time ago. which highlighted they made an ecological network in Romania, and it's important because this is at the national level. It's the only map that we have that exists at the national level. We took this old map. This is an old JPEG file which we had to digitize, so we had to redraw everything that is green, the map, light green. We had to update and integrate new ecological corridors which are not at the national level. So we had to integrate the results from Connect Green, for instance, which is a project that just had the Carpathians, the Carpathian area. So we had to integrate that in our digitized map. We had to identify the most recent motorway project routes, which is not easy because these data are pretty very easy to find. Then we had to do an intersection between ecological corridors and the motorway project routes in order to identify the changes in barriers and impermeable road sectors from 2008 to 2024. We also had to do a digitization of overpasses, the existing ones and the proposed ones. This is the result. So I know it's a bit much to take in at just seeing it for the first time. So we have two sets of lightning strikes, blue and yellow. The barriers in 2008, which were from the previous map, from the old Naturregio map, they are highlighted in blue. Some of these remained in 2024. They remained as barriers. No one did anything about it in the meantime. We also identified new barriers, and they are highlighted in yellow. So at the level of 2024, we have some which remained as existing barriers from 2008, and some of them which are new, as I said. These are mostly related to new motorway projects. So if a new project is proposed, there are, of course, new barriers which have to be taken into consideration. Excuse me. We also digitized and tried to find the impermeable road sectors. So in red, in this map, just red, we have impermeable national and county roads at the 2008 level, which became permeable, or we think that they became permeable in 2024 because of lower traffic levels. So if, let's say, if a motorway was built or is proposed in an area and that motorway has an ecoduct, our assumption is that the level of traffic will decrease because the motorway will take some of the traffic from the national road, and that national road will become more permeable, let's say. There are also some national and county roads from 2008 that will remain impermeable, and they are highlighted in this pink color. Here, there are quite a lot of them. And we also have potentially impermeable motorway sectors at the level of 2024. They are highlighted in blue. So you have, for instance, this one, which we don't actually know what's going to happen to it. It's possible that it will be an impermeable motorway sector because it's in a very difficult area. It's a mountain area, and it's probably going to, if permeability isn't assessed very well, it's probably going to be an impermeable sector. As an overview of results, we have a number of barriers which has increased significantly in 2004 compared to 2006. Should be 2008 there, sorry about that. So it's almost doubled, let's say. And this is because of new motorways, because of new express roads, which have been proposed in the meantime in Romania. The number of impermeable national and county road sectors has decreased a little bit. And the same is true for the length of these sectors. And that is because, as I said, new motorways have been built. They took some of the traffic from the national roads, the existing roads. The traffic on those roads decreased. So we think that they are more permeable than they were 15 years ago. As far as overpasses, We had none in 2008. We have 3 now. So that's, I think, better than 2008, but not ideal. We have 18 proposed overpasses. They were all proposed by us, so we know exactly where they are. It's where they are proposed. They were the projects we worked on in the last 10 years or so. So it's also interesting to see in these results that the number of overpasses of overall overpasses of 21 overpasses is much smaller than the number of barriers. It's quite significant. That it's quite important to say that probably the number of overpasses won't solve the barrier problems that might happen in these proposed projects. So as I said, the number of barriers has significantly increased by about 67% due to development of new projects. The number and length of impermeable road sectors has decreased because of new motorways, which attract the traffic. Some of these areas became permeable because of less traffic on the existing roads and a permeable motorway. The number of overpasses is very low compared to the number of barriers. And as a conclusion, we can say that fragmentations remain a significant problem in Romania and will probably remain for the foreseen future as well. Thank you very much. If you have any questions, or am I out of time?
Yeah, just a bit. Okay, we have time for one question. Quick question. Is there any? Okay.
Marie Rath from Austria. And I'm wondering, because you said authorities were not participating in the process, if you communicated the results and if they accepted that as a stand, like as a
not yet, not yet, but we are trying to have sort of an independent sort of assessment, let's say, or monitoring of the projects that are getting approved lately and that will be approved in the foreseen future. We want to have this map as a public resource, let's say. I don't know if they will adopt it or accept it or take it into consideration in any way. Fortunately, it's a bit more difficult to have a dialogue with the authorities.
Thank you.
Yeah, thanks again for presentation, Silvia. We will stay in Romania. There was mentioned Project Conegreen, and forget to say that this lightning talk will be given by me because my colleague Kristina Vlkova is in Greece right now. So I will hopefully quickly show you or present how this part of one of the input for this general map of whole Romania was prepared or developed, but for the focus of just for Carpathians. So the main aim of our part of this project, which already ended I don't know a few years ago, was to develop ecological network for the whole Carpathian region. So not just for Romania, but the Romanian part of Carpathians is the biggest one. And we were driven somehow by the concept of coarse corridors, carnivores, that when the corridors need to spread or somehow enlarge their territories, they need to use these not just the cores, which are somehow protected, but also functional corridors. So we start with the assessment of habitat suitability. According to this, we define core areas and stepping stones, and after evaluating the habitat connectivity between these core areas and stepping stone patches of suitable habitat, we try to identify the migration corridors. We start obviously with data collection, which was the enormous work of our, especially Romanian and Slovakian colleagues, but we had some nice data from Ukraine as well and Hungary too. Our work was generally to build the habitat suitability models, and according to this run the habitat connectivity models, and we participate on identification of migration corridors as well. We collect a really huge data set for the whole Carpathian region. I think that this is one of the greatest achievement of the whole project to set these data across the whole region, like international transboundary project. And then also it was quite challenging to set and standardize somehow the set of environment data because not all of these states are parts of the European Union. So especially for Ukrainian and Serbian part of Carpathian, it was quite challenging as well. According to this classical Mia-Maxent model, we prepare the particular models for lynx, wolf, and bear, and run some kind of synthesis, as you can see here. And this was the key element or key input for some next steps of the development of final ecological network. We use some kind of criteria and spatial requirements of large carnivores to set core areas and stepping stones as well. We also use some independent data sets of occurrence data of those species to somehow define the core areas and stepping stones the best way. And parallelly, we prepare according to inverse habitat suitability and adding the information about fragmentation geometry, so-called resistant surface, which was then used for final modeling of connectivity. We used the approach of omnidirectional connectivity. So actually we need to model this not just for Carpathians as it's shown here, but also for wider part of the whole region. And we use this this output of the connectivity model as a key element for definition of the corridors. In this step, we need to also involve some local experts and other partners from other countries, because we know quite well the landscape in Slovakia, but it really differ according to the land use intensity and also the type of barriers in different parts of Ukraine, Romania, and some other parts. So we run also some manual education and delineation of corridors, which was run by local experts. And also we prepared some specific classification of ecological network, not just to basic elements like core areas, stepping stones, and corridors, but as you can see, and it's also written in a paper which you can download in Journal of Maps, that there are like more detailed classification of this final ecological network. The online version could be downloaded. I'm not sure if those presentation would be somehow available for all participants, but I can send it the link or even the presentation to. And also we provide this network not just to all partners of the project, the connecting project, but also to other including some government bodies, for example, in Slovakia. So it works as a quite important input for evaluation of a new highway construction or so. So that's it. Thanks for attention. And I have to say special thanks to Kristina and Vladia, my colleagues, who were really great cooperators. Yeah, I consume almost all the time as well, but we have 1 minute left for some questions. Manu, I was afraid that you will ask me.
Spare the compliments because I like the whole thing and I support very much what you're doing. I just want to put a finger on a maybe sensitive issue. why did you use the inverse of the stability to make the permeability? Because my question is, then the assumption is that non-suitable habitat is not permeable. And the thing is, if you want to look at road passes and stuff like that, you're missing them all because the road overpass is not suitable. So, and you have fantastic data. Why don't you do a step selection?
Yeah, actually, it was like really speedy, or the presentation would not include all these steps. We have some specific model, or to say, we worked with data on these permeable structures. But it was not coherent for the whole region. We have quite nice data for Slovakia, but we have non-data for Serbia or Ukraine. So the model was quite rough, but that's why we used the let's say expert editing of the layer, who knows the landscape or the field the best. Yeah. In Czech Republic, it's or in other countries, data-rich countries like Norway or Italy, it would work quite well. Yep, I think that we are ready for next presentation, but I didn't prepare I don't know it will be the next one, but I will. Yeah.
Good afternoon. My name is Wilhelm. I'm from Southwest Germany and work at the Forest Research Institute of the state of Baden-Württemberg. And I'm going to give you a short talk to the General Wildlife Corridor Plan. If you're not familiar with Baden-Württemberg, that's an example how it can look. It's very green. It's got 30% covered with forest, got agriculture, wine, but also a very well-developed road network, railway network, and lots of settlement as well. So we do have a lot of habitat for wildlife, but also the need for a concept to connect those habitats. Therefore, the General Wildlife Corridor Plan exists. It is an independent, ecological, forest-related biotope network. It's an integral network, integral part of a cross-state biotope network. It's connected to other wildlife corridors in Switzerland, France, Bavaria, and Hessen. And it's modeled. It's based on environmental input as well as a least cost path models from 6 different species. It exists since 2012 and is compulsory by law since 2015. Ideally, those corridors should be 1,000 meters wide to accommodate a variety of species and to make room for different landscapes. Of course, this looks pretty straightforward, but it's not as easy like it is, because we do have a lot of roads and we do have a lot of settlements. We do also have a lot of obstacles. The black dots are sections where the corridors are less than 1,000 meters wide due to unsuitable land use, commercial areas or airfields, mining, all of, different stuff. We analyzed the situation in 2012 and again in 2022, and it quadrupled during that time. And we do have about 120 sections where the corridors are less than 1 kilometer wide. The red, orange, and yellow dots are crossing sections with linear infrastructure, which are relevant to reconnectivity. There are many more crossings with local roads. They are not even considered. So the red dots are highways and federal roads with over 15,000 vehicles per day. So they are considered total barriers. I want to zoom in to one section. Oh, yeah. It's around up here. Just to give you an example. that are the corridors which connect the forests on the shortest way possible, and they have to pass lots of infrastructure, agriculture, and especially this section. I will zoom in a little bit more. Is less than 250 meters wide due to commercial development. And if one of those factories develops a little bit more, it shuts down a whole corridor. So, yeah, they are very crucial to monitor. But actually, this one's a good example. This federal road gets an update and gets 2 more lanes. And with this, a green bridge will be constructed and the corridor will develop until the forest. Oh, the whole corridor will be developed. The take-home messages, the wildlife corridors are, of course, under pressure, especially from development. And the reconnectivity over linear infrastructure is way too slow. Only one green bridge was constructed during the last 10 years in proximity to those corridors. But still the concept is a success. The name and the concept is known due to my colleague who developed it and did a lot of talking and a lot of workshops beforehand, but it paid off as he took hunting societies, forestry, and local representatives into account. They did a lot of workshops to find a good solution. It's not only modeled, it's also discussed. But yeah, it paid off. They are defined, so they are taken in account with planning. And we do see that we have wildlife vehicle collisions from lynx, wolf, and wildcat migrating endangered mammals in Baden-Württemberg in quite a proximity to those. So they are working. And yeah, it's a good thing to keep the last pathways open. Thank you. Any question?
And question. There is one.
Hi, I'm Elke Hahn from Vienna, Austria. You said these corridors must be taken into account in special planning. Is that a legal obligation or is that a goodwill thing?
Kind of both. It has to evaluate it if there's another option. It's not a definitely no, but it has to be taken into account with all the other factors that go into the planning. But we can, it's not a strict no, but they have to be taken in account and weighted against all other factors.
Who said that?
It's in the law.
Ah, okay. In the nature conservation. Thank you.
I'm Thomas. I'm also from Vienna, from the Federal Railways. I wanted to ask you, is there also a political target to when these corridors have to be reconnected again? Is there a political target set for that?
There is a political target concerning the crossing structures, but it's not met. So it's way behind.
Yeah, any other comments or questions? So I would like just to ask. So sorry. Yeah, don't turn.
Probably we should consider the same as Kart talked and what we are trying to do in Estonia, that is wildlife passage protection zone.
We do have protecting, like hunting is forbidden around it. And yeah, it depends on the land ownership, what's happening. So that's
put some special protection bottlenecks.
Yeah.
Thanks.
Last question.
How did you define the width of the bottleneck? Is this based on the species you selected?
Yeah, it was a workshop like 15 years ago where different experts agreed on 1,000 meters. Because it's not only for the big mammals, but it should accommodate for a variety. So, yes.
I wonder how was the situation in other states of Germany? Somehow similar or complementary?
I think Baden-Württemberg is one of the densest, like the conflict is pretty strong. So we do have a lot of nature, but it's also very attractive for industry and for, so we don't have a lot of open space here.
Well, we have to move to next lightning talk, which is about the ArcGIS tool using for pollution functional ecological corridors in Limburg. So I don't know where Thomas or Jan or
Jan
so,
is this working?
Yeah. Yep.
First, I want to say congratulations. It's hot in here. You are still here. Normally, the attention can last for 45 minutes. It's 1 hour and a half already here. No worries, 2 more to go. So I'm Jan Mampai, and I work for the Provincial Nature Center in Limburg and Flanders. And we are part of a regional government, and there we are involved in biodiversity policy. And ecological corridors are a major concern that we take in account. But we are there. You saw this kind of map already before, and we are in the most fragmented area of Europe. So fragmented that some other presenters showed it as a white space where no ecological connections are possible. I understand that. But nevertheless, we try. And it's bad. It's so bad that you cannot walk 300 meters in a straight line without encountering a road or a railway or a canal or something. So there we try to make ecological corridors. And I will present a tool that is made by a colleague of mine for communication with non-specialist stakeholders. And so now, please, all forget 90% of what you know about ecological connectivity, and then you can follow my presentation, okay? So it's made for people who work for a local government, involved in biodiversity, but not specialized in connectivity, or for working for an NGO and doing quite the same. We got a lot of questions, too much questions, so we thought we have to organize something. A few years ago, we made a tool for us to predict the opportunities for the realization of ecological corridors in the whole GIS system. So we made for our province a whole exercise, which is made of, we linked species information, more than 200 species, observation of those species with the habitats, and we connect the species information into 5 ecosystem groups: farmland and grassland, heathland, woodland, pools and ponds, streams and rivers. And then we made lines, possible opportunities for ecological connections. And we had 3 layers in the map. We had species observations. So it must be functional for a species. So if the species is not there, it doesn't make sense. we use vegetation, the habitat of the species, and we add a layer of policy. Where are already protected area for certain species? So, okay, then we make a line. Now, very important, we don't have money. So we don't make any corridors. We have a method, we have data, and we have knowledge, but we don't make them. It's our partners who made them in other projects that are in the region. So we have to network and talk a lot with other people who are not specialized in ecological connectivity. And first we made some reports. For every community, we made a report. You can find them here. They're all in Dutch, so you can understand it perfectly. But that was a problem because it's just a PDF. So all the maps look like this. So you can see on the map some lines. These are the ecological connections for pools and ponds. You can see some places like this. This is a species observation. And you see other polygons, and that is vegetation and policy areas. But to interpret this kind of map, not so easy, especially if you are not specialized in ecological connectivity. So instead of less questions, we got more questions. So we decided to change the same map into this system that our partners can use. And we made it in the easiest way we could imagine. So look, there is a zoom option. Very important. If we zoom, we come to this one. And we have a lot of layers, and we can delete some layers. Look, I go back. You see, the policy layer is deleted. So now you can see more the vegetation. It can be interesting for some projects. And even you can delete the vegetation. So you have only the species observation and the potential ecological corridors. But we did more. You can make a PDF from this tool, adding a legend. And so you can make the perfect place, the perfect map for your local politicians. And if you point on the map in a certain place, you click, then you see the legend too, which is very interesting if you are not specialized in ecological connectivity. So that's what we made, and that's what we try to communicate. Now, we regularly meet with partners from other provinces because it only exists now in our province. And as long as we stay in Flanders, okay, same data layers, possible. But it becomes much more difficult if we meet with organizations abroad, because their maps are different, policy map is completely different, and things is more difficult to think and make projects over boards. So we are always interested in sharing our new insights, and I'm here to hear a lot of insights from you. And this tool is now tested and will be released to our stakeholders next month. And I just wonder if it would be possible that IENE makes something on European scale. Maybe for some species. I heard somebody who already was working. Okay, that will be it. So now you can add the 90% of what you know about ecological corridors again. Thank you.
Thanks for a very instructional presentation for further use in other countries. Are there any questions or comments? See anybody? Ah, there is one.
The question is a comment. I think Belgium is quite interesting because so we don't have much nature left. But the thing is, you know everything about the nature we have. So I feel that wouldn't you be able to collaborate with researchers to do this a bit more kind of structurally? Because I think this is a very interesting case for everybody. I think there's a gradient in the middle between countries that have a lot of land and not much infrastructure, and countries like Belgium, sorry, but it's quite impacted. So I think it would be very, very, very important to develop this further, not just leave it as a polygon, which is interesting, but I think you can maybe validate it with the biodiversity. You can compare and see whether the models made in other countries can fit in Belgium or vice versa, because you know everything about Belgium. I mean, you know everything about what is in there, right?
Yeah, look, that's going on. It's a process of collaboration. We recently are thinking together with University of Antwerp together to make one system. They have their system, we have our IDs and our information. So we're working on it. And indeed, it's very interesting, Florence. True.
Okay, thank you one more time. And the last lightning talk of our session is going to be given by Jana Prados about exploring the drivers of spatial temporal changes in urban and rural infrastructure development, the Czech Republic.
I have one question. Have you ever considered the road more like veins and artery body? Survival of vital components such as one area and our ecosystem. Have you ever thought about this before? Imagine that roads suddenly can stop unpredictably or change direction or probably get confused. I think it's not a scenario. Our road, it's not just a pathway, it's lifelines. Not all people think about this in this direction. But however, poorly planned road can lead to traffic, to high maintenance cost, to fragmentation, and I don't know, increasing pollution and so on, so on. Urban area for today cover approximately 6% of our Earth. Nevertheless, nearly 60% of all population live in urban and peri-urban areas. That's why today necessity for urban and rural landscape is to be not only functional, but also keep sustainability and balance. The word balance I like more than word sustainability because it's like a little bit utopia for me, sustainability. Everything changed in our world. My ongoing project, I choose some questions During my research, I will use ArcGIS software and QGIS as well. And for main question is to analyze change of transportation over last approximately 200 years to verify existence of these changes and identify driving forces and calculate and analyze quantity and quality, which is more important, of changes in area, and finalize my project to conduct environmental impact on ecosystem. So let's get started. My research cover all Czech Republic area. For beginning, I choose randomly 60 area. Each area is 4 square kilometer, and total area it's 2040 kilometer. I use ArcGIS and sportive just to control my error, QGIS as well. And it's cover, it's taken from Czech cadastral main page. After that, based on landscape classification of Romportl as well, I combined different, it's not all levels, but I tried to express it to show you how it's working by visualization. So I collect data, I combine different type of countries and cover and elevation, topo map. I use as well cadastral map to minimize error. And I focus my work on roads and urban area. Then I divided, which is more important because I analyze change over the time. I divided my project for 2-3 time horizon for 1850, 200 years ago, present time, and between this area in the intermediate period, it's 1950. Between these two periods, it was chosen because we want to analyze trajectory, why it's changed, in which way it's changed, not just show that it was some changes. This is example. So example between the past. So I georeferenced old map. We were calculating here is building area and road as well. Then I calculated road for past and for present. And after that, I should to using ArcGIS, I calculate continuous road and build up area, merge and extinct using JS like intersect. I think you know this. Or erase as well. And I have already some data done. On the top, this road from past and future and present, and this is build-up area. We can see that, for example, today build-up area is very is grown so like discrepancy in growing, but nevertheless the road here is still like have same amount. Why it's like this? I have assumption that this is 4 different area. I just choose to show you that urban area grow not only in horizontal way, but also in vertical way. Road, I mean road in Europe, not in China, where it's road you have 25. In Europe, road usually grow by horizontal way and we can say about road density. Right? And this is example, for example, this area is in Prague, and some area so far away, rural area. And conclusion, because my project's still going on, next month I will test statistically driving forces. Why it's change? The change is logically that, yes, we understand this. And for these changes, we will choose an independent and dependent variable. For instance, it's changed because of urbanization, because of planning or economic consideration. Why I'm doing this? It's because of our future landscape planning. The word future, not all people really deeply understand, because future in a minute, it's already the future. Yes. Therefore, the way we design road, city, and life affect human lifestyle and biodiversity of tomorrow. Thank you for your attention.
Thanks, Jana, for the last presentation of this session. Are there any questions? Everybody? Okay, there is a question.
Hello, thank you. It's very interesting. It's a huge effort to digitize old maps because you have to probably hand draw it all. The question that I have, is it clear that the samples that you choose are representative for the rest of the Czech Republic? I see that there are only very few tiles over the whole area of the Czech Republic chosen, and my question is if you know how representative they are for the whole country.
This area, it was chosen randomly without any intention, and honestly, we discussed with my supervisor, yes, how it's work, and we decided it will be a equal square rectangular form. We just choose using ArcGIS function strata, okay, and we choose this these areas there covering all Czech Republic, from highland to lowland, and after that I just analyze each square, and I can see, okay, this square have higher percent of urban area, another square, for example, for today it's in forest area, but I can see that for, before 200 years it was village, okay, or sometimes here is opposite side, it was village and now is some small city, and it's road change as well, and I already see this, and I start thinking why it's disappearing, this village, because usually we can say, oh, it's growing, but I see not all area growing. And sometimes it was village, now it's become city, or sometimes it happened like this. It was village and now it's urban area, industrial zone. Sorry, not urban, industrial zone. So it's, then I will think after my statistical experiments and hypothesis.
Yeah, any other questions? Everybody's looking forward to get out with the hot box outside to. Okay, so thanks for your for coming for this session. Enjoy not just coffee break, but other sessions, and see you around.